Bismillahirrahmanirrahim. Assalamu alaikum, dear student. Welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus Punjab Book Foundation Physics SSC2 Unit number 14 Current Electricity. Today we will discuss about SLO base according to FBISC requirement numerical problems question number 9 to 11 in part 3. Now we will start today's lesson in numerical problem question number 9 given statement. A house is installed with number 1, 10 bulbs of 60 volt, each of which are used 5 hours in daily. In B part, 4 fans of 50 volt, each of which runs 10 hours daily. And in C part, 1 TV of 100 volt, which is used for 5 hours in daily. Now, in D part, an electric iron of 1,000 watt, which is used for 2 hours in daily. Now we can calculate the cost of 1 unit of electricity is Rs 4 rupees. Find the monthly expenditure of electricity, and 1 month is equal to 30 days. First of all, according to the statement, we can write the given data. Power of 10 bulbs, that is equal to 60 multiplied by 10, that is equal to 600 volt. Now in B part, power of 4 fans, that is equal to 75 multiplied by 4 is equal to 300 watt. And similarly in C part, power of iron, that is equal to 1 multiplied by 1000, that is equal to 1000 watt. In D part, power of 1 TV, that is equal to 1 multiplied by 250, that is equal to 250 watt. Now we can solve and require that in numerical problem question number 9, monthly cost of electricity house. In formula, energy is equal to horse multiplied by power divided by 1000. Now we can calculate energy consumed by the bulb, that is equal to R multiplied by power multiplied divided by 1000. Now the energy consumed by bulb E is equal to 600 multiplied by 5 or multiplied by 30 days divided by 1000. So energy consumed by bulb is 90 units. Similarly, energy consumed by fan, that is equal to E is equal to R multiplied by power divided by 1000. That is equal to 300 multiplied by 10 or multiplied by 30 days divided by 1000. That is equal to 90 units. Similarly, in C part, energy consumed by TV, that is equal to R multiplied by power divided by 1000. So energy E is equal to 250 multiplied by 2 hours multiplied by 30 days divided by 1000. So energy E is equal to 15 units. Similarly, we can find that energy consumed by iron, that is equal to R multiplied by power divided by 1000. So energy is equal to 1000 watt power multiplied by 2 or multiplied by 30. So that is equal to 60 units. Now we can find the total energy consumed by 90 multiply plus 90 plus 60 plus 15, that is equal to 255 watt. Now we can calculate the cost. So price of electricity is equal to 255 multiplied by 4, that is equal to 1020 rupees. Similarly, we can solve the result. Total price of cost 1020 rupees. Now, in numerical problems, question number 10, given statement. A 100-watt lamp bulb and 4 kilowatt water heater are connecting in a 250-watt supply. Calculate the current which follows in each appliance and the resistance of each. Now we can write the given data according to the statement. Power P1 is equal to 100, power P2 is equal to 4 kilowatt. That is equal to 4 multiplied by 10 raised to power 3 watt, because 1 kilo is equal to 10 raised to power 3 and voltage V is equal to 250 watt. Now required that current I1 is equal to question mark, I2 is equal to question mark, and B R1 similarly R2. Now we can find the formula. Power P is equal to IV, and according to Ohm's law V is equal to IR. So first of all we can find the electric current. P1 is equal to V I1. I1 is equal to P1 upon V. That is equal to 100 divided by 250. So this implies that I1 is equal to 0.4 ampere. Similarly, P2 is equal to VI2. This implies that I2 is equal to P2 over V. That is equal to 4000 divided by 250. This implies that I2 is equal to 16 ampere. Similarly, we can calculate the resistance by the Ohm's law. In B part, V is equal to I1 R1. So R1 is equal to V upon I1. This implies that 250 divided by 0.4. So R1 is equal to 625 ohm. And in second part, V is equal to I2 R2, that is equal to R2 is equal to V upon I2. So 250 divided by 16, that is equal to 15.125 ohm. Then the result of this question, I1 is equal to 0.4 ampere and I2 is equal to 16 ampere. Similarly, R1 is equal to 625 and R2 is equal to 15.125. Now we can solve the last numerical problem, question number 11. In question number 11, given statement, a resistor of resistance is 5.6 ohm is connecting across a battery of 3 volt. Mean by the wire, show the resistance. A current of 0.5 ampere pass through the resistor. Calculate the number 1 power, and number B we can calculate the total power produced by the battery. Now in C part, give the reason of different potential of these two equal quantities, or we can say that between the two quantities. Now according to the given statement, write given data. Resistance R1 or R is equal to 5.6 ohm and V is equal to 3 watt and I is equal to 0.5 ampere. We can require in A part power, and in B part power of battery, and in C part reason of difference between the two quantities. Now in A part we can use the formula P is equal to I square R, and in B part we can use the formula power P is equal to IV, and we can calculate the solution. A is equal to P is equal to I square R, putting the values 0.5 square multiplied by 5.6. So the power in the resistor. So P is equal to 1.4 watt. Similarly, we can calculate the B part. In B part, power of battery. So P battery is equal to VI. Value of V is 3 and I is 0.5. So power of battery is 1.5 volt. Similarly, we can find the result. So in A part, power P is equal to 1.5 volt and power of battery P is equal to 1.5 volt. So in C part, we can write the simple answer. That is, we can say that some power is lost by the internal resistance of battery. Best of luck. Subscribe my channel